by 2 because of time. So 2 by 2, let's choose difficulty 4 and let's go. I have the alphabet, the letters which help me choose what position. So say I want this 5, I'll choose A because that's the corresponding letter A, and say I want to go right, and then the AI makes it move on B right, and we can just continue. So I'll go for A down. Yeah, I went for D down, and then we can go for T up. So yeah, the AI just got me. It made me lose. It kind of made me pick a box which I didn't need to, and then it got me by getting these 2 5s and the 2 as well. So yeah, I can show you the code and how it's modeled. So this is just a simple solver, and okay, so here we have the node class, which has a lot of variables, but this basically represents the board. And so here we have a 2D array made of tiles, and tiles are basically, as you can see over here, 5, 2, 5, 4. These are all tiles, and they're made up of values, so like the numbers, and they're made up of directions, so up, down, left, right. And we can set these directions true or false based on whether there's a line or not, and we basically use that to actually make the lines, and to see if there's a box around a tile. So back to node, there are these other variables. These are all just little variables. So we have a string representation of the board. We have the players. We have a player object, which is basically the max and min. So max is you and min is the AI. We also have a toggle, which helps us choose which player is acting on the current board, and that's just a true or false value. And then we have depth and a bunch of other things. So let's go to the most important function, which would be make line over here. So make line, we would get a position, and we would get a line. So that'd be like a C and down, or let's just say A and up. And so if we get like an A and up, the board will check for an A over here, and if it is an A, then we'll go check for an up. And the first check is to check if there has already been a line up there, which just checks a true or false value. If there hasn't, then it makes the line, it puts it in the string version, and then it checks that tile. Every time it makes a line, it checks that tile to see if it's closed or not. Then if the line that we made is kind of like a border line, so it shares it between 2 tiles, then we get the corresponding tile, so on the other side, and we set that as true as well, and we basically do that. So we check that at every direction, and then we change the toggle right at the end to say, oh, next time we make a line, it's going to be the next player's turn. And that's pretty much it. There's not many other, the other methods are pretty small. So this is the Minimax class, and the Minimax class has 4 methods. It has Minimax, max value, min value, and successor and utility. Utility is just a simple player 1 score minus player 2 score, and that gives us the evaluation of the board. Successor just gives us the children of any given state. And then we start with a Minimax function, which will return a set of instructions. So for example, it will return A left, or B down, or D up, depending on the best move the AI should make. So it takes a state and it passes it to min value. The reason min value is because the AI is the second player and it's looking for the smallest value. So min value will give us the smallest score from a bunch of nodes, and it's recursive. So let's go to min value over here. So as you can see, it checks if it's terminal or if it's the depth state, so then we can actually evaluate it from the final state. If it's not, we get a bunch of the state successes, and we pass it to the max value, where we'll get a value back, and we use that value to choose a minimum. So we keep doing that. So from all the successes, we end up with a minimum. That minimum is this v, which we return, and we also set it to the node. So this is the v that will percolate up from the smallest place, and max value is just identical except it looks for the max. So these two v's, the returns, those are the values that go up, and at each point they're set with it, they're given to the current state node, so it saves it. And then eventually when we get to min-max, we have a bunch of children, and the children that have that value v, that's the one that's returned. That's the set of instructions that's returned.